Good morning. I am Professor A.K. Patnaik. I have started the Core 2 course Physical Chemistry, gas state. Last class I have discussed about the kinetic theory of gases, derived the kinetic gas equation and discussed the derivation of mean free path and viscosity. And today we will see the relationship between the derivation of relationship between mean free path and viscosity. Today we will derive the relationship between the mean free path and the viscosity of the gas. Let us see again what is mean free path. Now suppose you consider a gas in a vessel. According to kinetic theory of gases, these are the molecules. So the gas, according to kinetic theory of gases, the vessel contains some gas, means it is filled up with the gas molecules, and the gas molecules are randomly moving in all possible directions. They are striking with each other. Let us say what is the mean free path. Now suppose we target this molecule. This is suppose the molecule is a molecule. So this molecule starts and strikes with this, then strikes with this, then strikes with this, then strikes with this, and strikes with it like this. So the mean free path means the distance travelled by a molecule between two collision is called free path. Now mean free path is the average distance travelled by a molecule between two successive collision. Now this molecule starts here, it collides with this molecule. So this is one distance travelled, that is called L1, free path. This is the free path. Again it travels with this, it collides with this molecule, it travels the distance L2. Then it collides with this molecule, travels with the distance L3. Then collides with this molecule, travels with the distance L4. Then it collides with this molecule, travels with the distance L5. So these are the free path when molecule travels. So mean free path means mean of this free path means the mean of distance travelled by two successive collision is called mean free path. So the mean free path is expressed as L1 plus L2 plus L3 plus L4 plus L5 by number of collisions. This is your mean free path. That means the distance travelled here, there and here are not same. On each time the distance are not same, they are different. L1 is not same as L2, or L2 is not same as L3, or L3 is not same as L4, L4 is not same as L5. So you take average of this and the number of collision, this is 1 collision, this is 2 collision, this is 3 collision, this is 4 collision, 5 collision, divided by 5 gives you the mean free path. The distance travelled by the molecule between two successive collision divided by the number of collisions. So this is 2 collision 1 distance, this 2 collision 1 distance, this is 2 collision 1 distance, this 2 collision 1 distance. So these are the average distance divided by number of collision gives you the mean free path. Now let us see what is viscosity. What is viscosity? I have already discussed what is viscosity. Now if you consider a flowing of gas in a tube, so when the gas is flowing in a tube, they are in different layers. So they are moving in different layers. So this is your, if you consider this is your tube, this is you consider the tube, then this is the first layer, the layer which is contact with the wall is called to your velocity 0. Now the another layer, this is your velocity V1, this is the velocity V2. This is the layer with velocity V3. So if you go on upward, then the velocity of the layer increases. The layer which is close contact with that of the wall, this is your velocity is equal to V0. The layer which is in contact with the wall, velocity is 0. Gradually the velocity of the layer increases and becomes maximum at the middle of the tube. This is the middle of the tube, the velocity of the layer is maximum. Now, that means the difference between these velocity are very small. The difference between these velocity are very small. Then what is viscosity? If you apply a certain force so that the velocity between the layers remain constant, that is called your velocity is remain constant, maintain a constant velocity, that force is called your viscosity. So, viscosity is expressed as you know F by A into dV by dx, where dV is the distance between the difference of velocity between the layers and dx is the distance between the layers. So, this is called velocity gradient. This is called velocity gradient. This is called velocity gradient. Now, if velocity gradient is 1 and the area of where the force applies is equal to 1 centimeter square, then viscosity is equal to the force. So, viscosity is defined as the force which is applied on unit area to maintain the unity velocity gradient. So, viscosity is the force which is applied in unit area to maintain the unity velocity gradient. This is called viscosity. So, now we will derive a relationship between the mean free path and well as the viscosity. So, let us consider a gas is flowing through a tube. So, this is the layer where velocity is equal to 0. Now, consider certain layers. This is one layer, this is another layer, this is another layer like this. This is layer number is A, this layer is B and this layer is C. The height of the layer A, let it equal to h, and the distance between these layers is equal to L. This layer is equal to L, where L is the layer. These are the molecules moving in this layer. So, these L are the called mean free path. So, L is called mean free path. That is the distance between the layers, mean free path. Where h is any height, you can take here. So, h is any height of the layer. Now, let us consider between these three layers. In this layer, you consider the momentum transfer from B to A. Consider the layer A. The momentum is transferred from B to A. Here, the momentum is transferred from C to A. That means this momentum is transferred upward and this momentum is transferred downward. The molecules are moving here to here upward, the molecules are moving here to here downward. So, the velocity of the layer, how much is equal to height into q, where q is called velocity gradient, where q is equal to velocity gradient. Now, we will calculate then the relationship between the mean free path and viscosity. That means L and N eta value. Now, let us see now the velocity of the molecules. The velocity of molecules moving in layer B, How will calculate? The height of the layer B and into the velocity gradient. Height of the layer B means, what is the height of layer this? This is equal to h minus L into q from the ground state, from the ground level of the layer distance is equal to the layer distance h minus L into q. So, the velocity of molecules moving in layer C, the velocity of molecules moving in this layer C, how much? That is equal to height into velocity gradient. This height is equal to h plus L, that is h plus L into q. So, this is the velocity of molecules moving in layer B, height into velocity gradient, and this is the velocity of molecules moving in layer C, H plus L into Q. Now let us see how many molecules are here, how many molecules are moving downward and how many molecules are moving upward. If you know number of molecules, mass of the molecules and this velocity, then you can calculate how much of the momentum is transferred from B to A and C to A. Now let us see that when the molecules are moving in 3 different directions. So number of molecules are moving 3 different means 1/3 of the molecules are moving in one direction. So we are considering only x-axis value, that means 1/3 of the total number of molecules are moving in x-axis in this direction. So 1/3 of molecules are moving in one direction, are moving in one direction. We are considering only one direction, this direction. So 1/3 of molecules are moving in one direction. Out of 1/3 molecules, half of the molecules are moving in backward direction, downward direction, and half of the molecules are moving in upward direction to A. So that means 1/6 of molecules, that is 1/6 of molecules are moving upward and 1/6 of molecules are moving downward. Let's see how many number of molecules are moving upward and how many molecules are moving downward. Let n is the number of molecules per cc or centimeter cube. Let the n is the number of molecules per centimeter cube, and let v is the average velocity of each molecule, average velocity of molecules of the gas. So the number of molecules with a velocity v moving upward is equal to 1/6 n into v bar. Similarly, number of molecules with velocity v bar moving downward, 1/6 n into v. Now calculate what is the momentum transfer. Due to momentum of the molecules, the momentum transfer per second. The momentum transfer per second moving upward. The number of molecules, mass of the molecules is what is the number of molecules, what is its mass, and the velocity of the molecules. What is the mass? If m is the mass of molecule, each molecule, if m is the mass of each molecule, mass of each molecule. So the number of molecules is how much? 1/6. So the momentum transfer is equal to total mass, that is equal to 1/6 m n v bar, total mass into velocity. When moving upward, the velocity is equal to how much? H minus L into Q. So this is the momentum transfer due to moment of the transfer per second due to movement of molecules from layer B to from layer A. That is from moving upward means B to A. So the momentum transfer per second due to movement of molecules upward, downward, movement of molecules downward. So the momentum transfer per second due to movement of molecules downward, that is from C to A, will be equal to how much? The total mass into, what is total mass? 1/6 m n v bar into velocity, that is equal to h plus L into Q. So when the momentum transfer per second from the from B to A is 1/6 m n v bar h L minus into Q, and the momentum transfer per second due to movement of the molecules from C to A downward, that is equal to m into n into v bar h plus L cube. Now, what is the net momentum transfer per second due to movement of molecules from one layer to the other layer? So, the momentum transfer, that is called net momentum transfer due to movement of molecules, net momentum transfer per second due to movement of molecules from B to A and C to A. This is equal to how much? That is 1 by 6 m n v square bar h minus L q minus h plus L q minus 1 by 6 m n v bar h minus L into q. So, take this is common, 1 by 6 m n v bar q is common. So, this is L plus L minus h plus L. So, that is equal to 1 by 6 m n v bar q into 2 into L, where 2 will cancel, that is equal to 3. So, this is equal to 1 by 3 m n u bar q into L. So, this is the momentum transfer per second. Momentum transfer per second is equal to force. So, this is equal to the force. So, this is equal to the force for unity. If the area is unity, if A is 1 square centimeter, area unit area is 1 square centimeter, and velocity gradient is equal to 1, then this force becomes viscosity. So, viscosity will becomes 1 by 3 m n v bar q is equal to 1, so into L. So, this is the expression relationship. This is the relationship between viscosity and mean free path. So, the relationship between the viscosity and mean free path eta is equal to 1 by 3 m n v bar into L. This is the relationship between the viscosity and the mean free path. This is the relationship between viscosity and mean free path. Now, this is the, if you multiply m into n, we will get the molecular mass. So, if you know the molecular mass of a gas and this velocity and a free length, then you can calculate the viscosity. So, from this relation you can calculate the viscosity, or we can measure the experimental viscosity, and you knowing this average velocity calculating, we can calculate what is the mean free path of the gas molecules. Now, what is the, how to get this? This velocity is equal to, this is your most probable velocity. So, this velocity we can calculate 0.921 into RMS velocity. That is equal to, V bar is equal to 0.921 into root over twice RT by M. So, if you know the molecular mass and the temperature, so you can calculate the average velocity. So, you can calculate the average velocity and we can measure the viscosity. So, you can calculate what is the mean free path. So, this is the advantage of this relation. One is theoretical value and other is the experimental value. By using the experimental value, we can calculate the theoretical value of mean free path. The second part is calculation of collision diameter from viscosity. Calculation of collision diameter from the viscosity. So, as you express in that one of the velocity is equal to 1 by 3 m n v square bar. So, this is equal to into L, where L is equal to 1 by root over 2 pi sigma square into n. So, eta is equal to, we can write this is equal to 1 by 3 m and v square bar. In place of L, you put this value 1 by root 2 pi sigma square into n. So, that is equal to, so n will be cancelled. So, it will be equal, eta is equal to m 1 by 3 m v bar by root over 2 pi sigma square. So, the relation is 1 by 3. So, this is the relationship between viscosity and the molecular diameter. What is molecular diameter? That is, the molecular diameter is when the two molecules are closest approach, the distance between the center of two molecules is called molecular diameter, sigma. So, this is molecular diameter. We can calculate what is the value of molecular diameter from the measurement of the viscosity. Here we can also use this value, this v bar is equal to 0.921 into RMS velocity. By using this value, knowing the molecular mass and measuring the viscosity, you can calculate the collision diameter of a molecule. So, collision diameter of a molecule can be calculated by measuring only the viscosity of the gas. Now, let us have some problem. Number one problem is the viscosity coefficient of hydrogen is equal to 8.41 into 10 to the minus 5 poise at 0 degree centigrade and 1 atmosphere pressure. Calculate the mean free path. Second problem is calculate coefficient of viscosity of nitrogen at 300 Kelvin, where sigma is equal to 4 into 10 to the minus 8 centimeter. Now, you solve these two problems. In one case, you have to calculate the viscosity coefficient. In second case, you have to calculate the coefficient of viscosity from the molecular diameter. Here, we can calculate the viscosity coefficient is given, and we have to calculate the mean free path. Now, let us see what is the expression for mean free path. Alpha is equal to, question 1, alpha is equal to 1 by root 2 pi sigma square. Viscosity coefficient. So, viscosity is equal to 1 by 3 m n v bar into L. Now, from this relation first, the viscosity coefficient is given, you have to calculate the mean free path. So, we will use this relation between the viscosity coefficient and mean free path. This value is given, that is called 8.41 into 10 to the power minus 5. So, if you take this, m into n is equal to molecular mass, that is equal to m into average velocity into L. So, this average velocity will be equal to 0.921 into root over twice RT by m. For hydrogen molecule, what is this? 0.921 into 2 into R. If you calculate the viscosity in poise and it is 1 centimeter, we have to use 8.31 into 10 to the power 7. Temperature is equal to 300. So, mass is to be expressed in 10 to the 7 centimeter. So, mass is expressed as for hydrogen, it is equal to 2. So, you can calculate what is this velocity. This velocity will be equal to 1.70 10 to the power 5, that is centimeter per second. This is the velocity. So, if you put this velocity, so 1 by 3 velocity viscosity is given, that is equal to 8.41 10 to the power minus 5 is equal to 1 by 3 into 2 into velocity 1.70 into 10 to the power 5, and you calculate the value of L. This L value will be 1.66 into 10 to the minus 5 centimeter. Now look at this problem. If you put all these values here, in this is given and this is known, you calculate, then find out what is the mean free path. So the mean free path value comes out to be 1.66 10 to the minus 5 centimeter. So from the viscosity value we can calculate the mean free path, or mean free path is given, we can calculate the viscosity. The second problem is calculate the coefficient of viscosity of nitrogen at 300 Kelvin. Sigma is given 4 into 10 to the minus 8 centimeter. So calculate coefficient of viscosity. So formula is N is equal to m into V bar by 3 into root 2 pi into sigma square. So here we can calculate the average velocity, that is equal to 0.921, sorry, this is not 2, this is 3. This is 3 RT, this is not 2, this is 3 RT. So this will be 3 RT by m 0.921 3 RT. We can calculate velocity. Then the value is, this is known, sigma, that is equal to, sigma is equal to 4 into 10 to the minus 8. You put this value square, you put this value, and you put the mass of the nitrogen molecule, that is, then you calculate the viscosity. This viscosity comes out to be 1.04 10 to the minus 4 poise. So from the molecular diameter we can calculate the viscosity coefficient, or from the viscosity coefficient you can calculate the molecular diameter, and from the viscosity coefficient you can calculate the mean free path. Thank you.